Today's episode, we're going to talk about making the nose, or more specifically, the plug for the nose. If I was beating the nose out of aluminum, which I was really tempted to do, this would be the buck for it. In this case, though, I'm making the nose out of carbon fiber, so it's kind of a plug. You could, if you wanted to manufacture these things, you could take what I'm building in this episode, make a mold off of it, and then use that mold to make noses. But I'm just making one. This isn't how things are manufactured. This is how prototyping usually works. So, starting with the core scale mock-up, this is just kind of a proof of concept. But generally, I took what I did here and applied this in plywood and plaster. So, once I'd found the shape I wanted, the curve I wanted for the fenders in profile, I took that, cut that out of plywood, screwed it together with some 2x4s and a third piece of plywood that's just flat that lays between them. That gives, it doesn't look like anything at this point, but that's giving most of the shape of the nose right there. The bit at the top of the flat piece of plywood that's open, that's going to have a piece of curved aluminum there to finish off the shape of the nose. It's got a curve there, which of course I'm not going to do in plywood. Then I make these cross-section pieces, or ribs. I did these by hand using a compass so I could do constant radiuses, and I would use a couple different radiuses, one for the outer side and for the inner side. And this was just kind of a shape I found through trial and error. And there's probably a better way of doing it, but I kind of lucked into something that seems to be working. How I made the rib sections, the cross sections, for shaping the nose, I'm not particularly skilled in this. If you've ever watched art majors do things, they've learned all kinds of tricks on how to transform three-dimensional objects into 2D and taking 2D back into 3D. And I just don't know that many of them. So just out of desperation, the first thing I did was draw kind of what I thought the shape should be for the fenders. And I don't know if you can see this line. This is actually how I started, and I decided to make it kind of fatter, just based on what I think looks cool. And then behind these lines behind it show where the chassis actually is, so I know where I'm covering the chassis. That the wheels should be fairly flush to this edge of the chassis. So this here is enough to cover the tops of the wheels. I also do things. I'm doing it here in scale, where any of these curves, I try to do them as just a series of constant radiuses. So I'll know, like, this says it's a 6-inch radius, and that's 6 inch in a 1-to-1 scale. So here that is 1.5. Yeah, I can do math. So this is a circle. This is a different circle. Originally I had a 16-inch radius going all the way down. What I ended up doing was making an 8-inch radius here. And then, so you've got this circle, and then you just connect them with straight, or here, I think I just did that kind of freehand. So what this does is give me, where the highest point is, which was this line here. This takes you to the highest point in the whole thing. And what the fattest kind of lines are, the width. So once I had those, this upper portion becomes the section of the widest rib, which I made 10 ribs, and so that turned out to be rib number 6. But so that gives me one set of data points. I've also got this, where here I kind of mapped out how it would look looking straight down, plan view, and here I do what I think is a nice looking curve for it, and I measure at all the spaces where the ribs are going to be, and I do the ribs 6 inches apart. This is the front of the vehicle here. And so these measurements here are scale, so you times each of these times 4 for what it's really going to be. So now I know, here's the width at its widest point. I have this, that we looked at first, this kind of general shape for it. And then I also have, doing it in profile, I created this curve, and here this is saying it's a 54-inch radius curve to here, and it kind of stops and then just does a straight line down. This I ended up I thought this would look better if this was angled, but for aerodynamic reasons, I stuck with how it is on a lot of cars of the era, and this just comes straight down now. So you'll notice that difference between this and what I'm building. This here is how the radiator will be, and it's actually the corner of it's going to stick up a little bit. This is GT40 radiators. What I'm doing, I already know the dimensions of it. I'm laying it down a little more flat. Anyways, coming back to this, I knew in between the fenders I was going to have a straight line to about here, and then it was going to curve. So then using this upper line, these were different angles that I tested. Using the upper line, I then measured, again, these are scale things, so you multiply all these distances by 4. This gives you the height that each of those ribs is going to be from that line. So then I translate that into, I actually just traced this upper section from that original front view thing that I showed you. This here represents where that plywood is. And the plywood of the side. I did a plywood section that has this on it. So then each of these ribs is just coming down a little bit, and there's probably a better way to do this. I thought later of like, maybe I should actually just be scaling them. Like I could do it on a computer, I could do it with a projector on the wall, or I could take, I'm thinking for the rear, I could actually take the shape of the fattest one and then just move it down for each bit that it's got to come down. We'll see if that works or not. But really, I mean, it's not completely freehand. It's because I went back over it with a Sharpie, and that makes it a little rougher because that was freehand. But again, I'm doing these were all 8-inch radiuses, 8-inch real life radiuses. These were, this is 8-inch. These were 6-inch, and then I made 5 3/4, 5. I try different things, and I look and I see, okay, how does that compare? Here, how does it compare here? I mean, this was all just kind of proof of concept. This is 1 up to 6, and then this is 7, 8, 9, 10 on the back, coming back down. I'm able to figure out then how far down it comes based on this. Although when I made the actual things, in plywood, I just used these as kind of general. This idea generally works, but I redid them all in plywood, and I was gonna do templates on graph paper, but I didn't have graph paper big enough, so I ended up just drawing each one on the plywood and then taking whatever the biggest one before. Once I had 6, I would then trace 6 where on the board where 5 was going to be cut out, and then use that to figure out where the 5th rib would be, and the 4th rib, and the 3rd rib, 6th rib, on and on. So to give an idea how this worked, let's do one. It's just kind of an example. The tool that's useful, this here, it's a compass that works on, it comes with its own ruler thing, but it's shorter. So I've put it on a full yardstick. So just as a quick example, I've got this junction between the 2 pieces of plywood. And this isn't going to go as far down as it should because my paper's not big enough, but just for demonstration purposes. So I know that this line here marks my highest point. So I'm going to say the highest point for, well, let's do rib 4, do rib 3 because it's going to be about 4 inches. So measure up 4 inches. Okay, so now I know my highest point has to be there. Do a 5.5 inch radius on this one. Okay, so 5.5 inch radius. Okay, so I just get that circle in. And then I need to know how wide this is going to be. So, rib 3, looking here, 4.5 roughly. So that's going to be 16. Yeah, it's going to be 18 inches. Jeez. Okay, so 18 inches. So if my widest point is here, no, it's over here now. that's my widest point. That means over there. It kind of helped when I was doing a bunch of these because I could just have off the top of my head what the previous radiuses I just used were. And this one, I'm not coming down there. I'm starting with a focal point, rotating point, anchor point down here. And see, that's not quite right because, oh, I should have pulled this circle in further. Because it should, that's not far off. Hold on, let's continue this a little further. Let's go back to 8. So I know I want this to be a little lower than that. So, no. Really didn't get that right. There we go. That was maybe too much. So let's see. So I'm just moving this anchor point around, trying to find there. That one looks good. And the more I did this, the better I got at it. But then I could just go like that, and then I would mark. I didn't have an eraser with me, but then I would mark this with a Sharpie, so I knew which line I was supposed to cut out with the jigsaw. And then down here it'd be a similar thing where there would be a 2-inch radius thing down at the bottom, which this paper's not long enough for, and that would connect at whatever angle, like this. And so that's how I made my ribs. I just cut them out with the jigsaw, and slid them in, cut little slots also with the jigsaw. Once that's in, then what you can do is take a long strip of metal or just a nice metal yardstick in good shape and flex it over them, and you'll be able to see if you're getting a nice smooth curve or if things are sticking out too far or not enough. So I've covered this side with duct tape, and I've run out of duct tape. When I get some more, I'll do the other side. The duct tape is there to help support what I'm going to do over it, which is plaster cloth. It's cloth with plaster, and you dip in water and you lay it over it, kind of like impregnated carbon fiber. But I'm going to do that to create the base structure, and then I'll just use plaster of Paris over it to smooth out where the ribs are and make everything actually a proper curve. And then I can sand that all smooth. I've never done anything like this before, and so right now I'm just kind of enjoying that this is kind of working. I've drawn on, and see where the wheel arch is going to be. If you look over here, you can see where there'll be a cutout for the radiator. And that's important to design. Tony Southgate goes on and on about how you get free front downforce from doing that. This tubing here in the front, this is something I learned to do when I was doing the Lotus. I actually wouldn't mind having bigger diameter tube, but this is just rubber tube that I've got with finishing nails in it going around, and this I'll plaster over this, but this gives me a nice rounded edge. There'll be brake duct inlets here, and then this will just be open. This goes to the radiator. I won't have a bottom here on the nose. I'll have sheet metal going out to an edge there. Okay, so while you've been gone, I've been working on the Can-Am car.
I see it already.
So let's come get your reactions. Come on.
It's already becoming a Can-Am car.
Wait a second. Were you confused which end was the front? That's not a good sign. Should I start over?
Well, it's just I thought you had like the radiator something going on, and then the nose, and then I just like looked at this as being the front, and I'm like, oh yeah, that's the front. And I think it's pretty good.
Really? I don't normally get that positive. What could be better?
That it's a Can-Am and it's Ferrari.
Oh, you mean you like it because it's a
Ferrari.
Okay.
Can-Am Ferrari.
Well, heck, I mean, the whole point of these bits is you're supposed to come out here and say, oh, this is no good, and you got to redo this, and I don't like the way this is. And
Although I do think the back is pretty short.
well, it doesn't have its back yet.
I mean, true.
The other thing the duct tape does is it gives you a little more structure for the next thing, which is we're going to plaster over it. And the first thing I did was, I grew up with my dad building model railroads, so I'm kind of doing this like you would a model railroad. It's also how you would make a piñata, or maybe do making a cast for a broken bone or something. This is the plaster wrap I've been using. So what you do, it's just cloth coated in plaster powder, and you just dip it in a bucket of water and put it on, and it forms pretty well to whatever the surface is you're doing. So use this, just layered it on. You want to build it up slowly because you don't want the tape underneath it to sag under the weight, because you are going to have to build this up. It's a curve, and in between those ribs, at best it's going to want to make a straight line, and at worst it's going to sag down, and you're going to have to build that up with plaster afterwards. Once this stuff is in and cured, I went over it with a pretty thick layer of plaster of Paris, and just kind of smearing this on, and then sanding the heck out of it with a belt sander, and then by hand. This gets the shape most of the way there, but then you can see where you need to build up and where you don't, and you could just keep going over this with more and more plaster. But what I was finding was, whenever I would sand down the spots where the ribs are, which were kind of high spots in my curves, when I would sand that down, once that got thin enough, the plaster would break off and kind of chunk out of there. So what I ended up doing, once I had done the plaster and sanded it down, is I ended up just deciding to joint compound over the whole thing. So this is it after I've smeared it all with joint compound. But rather than sand this, I'm just going to take a wet sponge to it and smooth it out, which, besides being less messy, means rather than sanding where I'm just removing stuff, I'm actually pushing the high stuff into the low stuff. This isn't quite dry, so it's still kind of malleable, which we'll see how that goes. The stuff isn't fully dry, so it's going kind of quickly right now, but you can see if I take that, this is just a wet sponge, you see how it smooths it out. So I'm going to do a pass on this, but I'll probably have to do another pass once it's dried more to get to that final spot of looking like it's been sanded smooth. And I might have to do a little hand sanding afterwards. Okay, this is the difference after having done the wet sponge. This side hasn't been done. This side's been done. It works good. An unexpected benefit is being all wet makes it shiny, and I can see all the low spots, which it's got quite a few. I'm going to try putting something firm like a board or a sanding block behind the sponge to see if I can get it to shape the joint compound a little more. This might be beyond, the joint compound's not that thick. But I'm going to try that. If that doesn't work, I think what I'll have to do is sand this a little more, and then probably do another thin coat of joint compound wherever I sand. It still kind of amazes me, because I kind of thought doing something like this was well beyond me. But then I still had to do a little bit of sanding. A nice sanding block just really straightens out things that are uneven. That takes us to where we are. Now the nose will have an opening for the radiator outlet. I'm not going to do the opening now. I'm going to do the opening. I'm going to do all the kind of edge work after after I've pulled it off of the plug. So I'm going to cut some holes there, and then I'm just going to lay some scrap pieces of aluminum I've got over this, because that makes it's a nice surface to put the mold release wax on. But it also won't be firmly attached, and so those holes will give me something that I can get the carbon fiber once it's laid up. I'll be able to push from underneath to help get that off. When you're doing something like this, you have to take into account how you're going to get what you're putting over it off. In this case, it's going to wrap around enough that there's not going to be any easy direction to put. There'll be an easier direction, but there won't be any guaranteed way where you'll be able to pull it off, because it will be holding it from one side or the other. You could do the plug in sections where you can take it apart. You can not carbon fiber, when I do the carbon fiber layup, you can not do it all the way around, wrapping around things that you then won't be able to get it off of, and do those in later sections. And I will be doing some of that in later sections, especially the bottom of the front of the nose. But the main trick I'm going to do in this case, and it's part of the reason I made it out of really thin plywood, is I'm just going to break up the mold underneath it to get it out of the carbon fiber. So that'll be the next video, is laying up the carbon fiber on this. And we're not going to do this in any high-tech way. We're going to do it just like you were making a piñata or a model railroad with paper mache, only we'll be doing it with sections of carbon fiber that we will wrap around what's there, and we'll layer it up and let it cure. So stay tuned for the next part where we actually make the nose.